So about this mic, should I mute this one?
No, it's actually you can see that it's not.
Oh, yeah. Okay. Hey. Yeah, there we go.
The stream is picking up this audio.
All right. So just about 5 minutes or so now, guys. Just bear with me. What's that? Yeah? Okay, great. So what I will be doing is, while you guys are speaking, I'm going to be switching my camera to this so that you can see the crowd while you're speaking, just so it doesn't feel like you're just speaking into the abyss. I'm trying my best just to make sure that you guys feel like you're here. So if you have any issues along the way, just feel free to let me know. But
we're used to talking to the abyss on Twitter all day.
All right. Cool. All right. Okay. You know what? I think we can get going. Okay. So thanks everyone for coming by in the rain today. Welcome to Program, and today we're doing a session on advanced DSPy. But before we kind of get into things, how many people is this their first program event? Okay, cool. I always ask that at the beginning. My name is Tarun. I started this program series a few months ago to kind of explore my curiosities around all of the new things that are coming out. It sort of turned into like a nice little kind of community project, and every one of these events is really a way for us to kind of explore something new, something interesting that's coming out. There's obviously, every day we see new tools that are becoming available to us, whether it's new open source, new creative tools, and these program events are just a way for us to like explore those new things, to do it not just solo in front of YouTube and just kind of watching tutorials all day, but to do it with a community, and then in the process also make something. So this is an event that I kind of like wanted to exist for myself, and it's turned into like a really fun community project. Every one of these is focused on a specific technology or tool. Today we're focused on DSPy, and it's actually our second event about DSPy. And what we're going to be doing is, the way that these events work is, the beginning of them are typically led by a workshop lead that basically talks about why they're interested in the technology, why they're working on it, and then we have about 45 minutes or to an hour of just like open builders time. It's like a kind of like a hackathon, and then at the end of the event we do kind of demos depending on how many people are open to demoing. Sometimes it's like we have 10 or 12 demos, sometimes we just have 5 or 6. So we'll see how things are going as the day progresses. Today is a very unique program event because we've never done anything where our speakers are actually remote. But super, super happy to be joined by two incredible individuals. First one is, I'm actually just going to put them up on the screen now. Just give me a second. There we go. Here we go. Max. So I am really, really happy to introduce you guys to two incredible individuals. First one is, to your right is Maxime Rivest, and to your left is Vikram. And Vikram you probably know as, if you follow the DSPy community, he's known as Spacy, or what's your Twitter handle? Dosco?
It's Dosco, D-O-S, yeah. I'll just put it in there.
Yeah, on Twitter. And both of them are, are leaders in the kind of DSPy community for their own individual reasons. Maxime is the author of this really incredible Python library called Attachments and is extremely active in the DSPy community. And Vikram is the maintainer of a DSPy library called Axe, which is a Typescript, should I call it a port? Like the Typescript port of DSPy in a sense?
It's just a TypeScript implementation.
Implementation of DSPy, yeah.
And is it maintainer or like full-on maker?
Both, yes, I sort of did so from scratch.
Yeah,
Right.
right.
And actually, I'm just going to transition everyone over on the live stream to this view.
To me, I thought we'd go for Vic first. Just, I don't mind. Yeah, go for it, Vic.
Hello, I'm Vikram. And I'm excited to sort of talk about this because, I talk about this on Twitter all the time. So, it's nice to talk to real human beings sometimes. And Tarun, thanks for inviting me. This is awesome. Max, it's great to sort of see you in person. All right, so I know this is titled DSP Advanced DSPy, but let me just say this. If you're using DSPy, that's Advanced DSPy because, we're sort of right at the ground floor here. I maintain something called AX. It had other names before, but it's been around since before, I would say, the models got this big. It was a library that started sort of leveraging BERT and stuff like that, these really small models. And the initial idea around that was, models are text in, text out. So we need scaffolding to sort of manage this. And along the way, I discovered the DSPy papers. And what really got me excited about them was, I'm going to call this talk pragmatic DSPy because that's always been my approach to it. It's not advanced or, any other thing. I've built a lot with DSPy. I've built several production things. Even right now, I'm working with a Valley company. We're trying to build some really cool stuff. It's all AX and DSPy. Okay, coming back to when I discovered DSPy, right? So my problem has always been, I first started off with AX, trying to abstract out all these LLMs and providers and, sort of that was my thing. Let's just have one interface into all of these. And then I increasingly realized that I was not reaching out for an LLM in my code. Why? Because it was a strange blob of text that you shoved in between your code. And I've been, developing software for a long time, and it's strange, and it's like it doesn't fit in with the rest of it. It's like putting SQL in your code suddenly. We don't like that. We like ORMs or something. So, and this was even stranger because this was like, instructions, and, you could never write them correctly. So I needed some sort of like a structure around this that appealed to me. And the only thing I actually saw in the DSPy papers was the concept of a DSPy signature. So what was a signature? Signature was basically taking this giant text heavy prompt and converting it into a set of inputs and set of outputs. We all know what functions are. So essentially it was a function. And what was more elegant was that the language, or you call it a language because it's just like in Python you write a function a certain way, in C you write in a certain way, in DSPy you write a function in a certain way. You put that little arrow notation, sort of looks like TypeScript. The advantage of that function was that function transformed into a prompt. So every choice you made in there, every word you put in there was actually it actually affected the prompt. And in addition to that, it was something that LLMs could themselves understand, generate. It was very LLM native, that signature. And that was sort of blew me away because I had seen a lot of like prompting libraries that use templates, and they all lean towards managing a lot of instructions. And I was never an instruction person. Considering I started with LLMs before they were like instruction following, like instruct tuned, because that's another layer on an LLM. It's not natural. I was more about in the example world early on, and I like that. So what is the example world, right? Like LLMs at their base are trained autoregressively, right? So they're trained to predict what comes after what comes before. And sort of like that mechanism allows you to put in examples, which as the LLM parses all of them in the attention mechanism, it knows what the next thing based on the patterns of the previous thing. So it's not instructions, but it's examples that help an LLM predict the right next thing. And DSPy took these set of inputs, set of outputs, and then allowed you to set examples for them. So it's like if you get these kind of inputs, you get these kind of outputs. What that does is an example is worth 1,000 instructions, sort of like an image, right? Because you don't know an instruction. Like what if I was trying to instruct an LLM to speak like Shakespeare, but still sound different? I don't know. I mean, that's hard to put instructions to explain that and how many, but I can give examples. And the LLM, what are LLMs good at? They're pattern recognition engines. They're able to, figure out things and functions from the input that, you and I cannot see or predict. So DSPy and, leveraging this in-context learning paradigm really made it powerful, right? I mean, you don't have to depend on the instruction tuning of a big hosted LLM. You could, you could work with any LLM, sort of like broke the lock-in. So that essentially and I was in my TypeScript world, I focused AX into making it this simplest thing you could grab and put into your code anywhere, like 50 times, 100 times, whatever, loop over it. And that sort of was my focus with AX, and it still is. It is about making it easier for developers to reach for an LLM. And why should you reach for an LLM? Why not just have one thing do it all, right? There's a lot about LLMs that I cannot explain. Even the people who are building them cannot explain. But essentially, there's a concept of budgets, right? There is a budget in the attention mechanism. Where does that budget come from? It comes from potentially every little thing you add into the attention mechanism sort of has to find a place in the mentessa of the the floats in there. And these are all probabilities. So they sort of kick out, they sort of push another thing down. There isn't space for everything, right? So every time you put more instructions or more tasks into the prompt, you're sort of crowding out something else. So even when you get an LLM to do JSON, people don't realize that, you're adding a task on the LLM's budget. And so you're taking away from something else. So the LLM's getting stupider for the main thing you wanted to do, right? So this is DSP. This is where DSPy sort of comes in, because having sets of inputs and outputs means you're not trying to get it to do everything. You're not saying, here's a question, and then I want you to output like 50 things. You don't write code this way. Why would you expect the LLM to? You break it up into smaller things that you then connect to each other like a tree of functions, just like any other program, right? So if you wanted to achieve some kind of an email thing, right, then you would set up one prompt to do classification, one for extraction. If you want to extract different things, you would group those and have different extraction prompts. You're not trying to get the LLM to do everything and output this big nested JSON. That's a bad idea to begin with. I'm not saying you can't do that, but but you're going to be stuck to the biggest models there are. You potentially have a higher failure rate. It's not going to be as smart as possible. And even the biggest LLMs, they struggle with JSON. If you've ever noticed, when you turn on, they have all these special flags you have to turn on. Why is that? Right? Extraction mode and blah, blah. You don't know if they're using a second model to try to like get that JSON correct. If you try to use function calling, you try to this, one thing is guaranteed, your prompt is slower. There's some reason why that's happening. Don't ask me. So there is, like DSPy basically, at least in AX, converts everything into, takes each one of those inputs and expands it sort of into an English word. So if you have like user request in like camel case, then that expands into like normal user space request : so it's sort of like a prefix. So then in the LLM now knows what comes after, right? It's self-documenting. So that's like the value of, I know there are different people that approach this differently with the concept of like prompt adapters or something where you can like tune. But in AX, I've stuck to this paradigm because I want to stick close to the auto-regressive nature of these LLMs. What comes before helps the LLM predict what comes after. And essentially, what I'm trying to urge you guys to do is reach for DSPy many times through your code, break down your problems, and build in that way. Tuning and stuff is great, optimizations are great, but those are further down the road. You're day one, you're trying to get something to work, you're trying to get it to work well, and then if this works, then you optimize it, and all of us in comp sci, you heard this always, right? Optimize later. So and I wouldn't even say I'm the biggest expert in that. Like optimizations, there's new stuff coming out every day. I've played with Bootstrapped a bunch. I've played with MIPRO a lot. I have just started exploring JEPA. I think they're all great. In fact, several times I have just used the inputs, outputs to generate, tuning JSON-L files, whatever you want to call them, and then upload them into the host LLM and get one of those provider companies to just tune a smaller model for me. That's worked fine as well, right? Like essentially, what else am I doing with AX if this is DSPy? Well, obviously it takes a lot more to productionize something, right? When you're generating several LLM calls, what if you're like 40 calls deep? You have a call that calls another thing, and then you're building giant systems. There's several things to make something production ready. You need, able to stream, you need to be able to handle things like assertions, you need to have type safety, you need to have metrics, you need to have tracing, you need to have, like, it just goes on. You need the ability to control, the token budgets sometimes, you need to be able to switch the model as the flow goes through. So like at this point, you wanted to have the classifier here, choose a different model here. There are like several things that, I have over the years added in because, AX has been around in production for a long time. And so my goal is, to basically take this basic DSPy idea and productionize it. So that's, the optimizations and stuff have always been an afterthought in AX. And I am working on that, but the essential idea was to productionize it everywhere. So AX today works in Node.js, works in Dino and all these other things, but it also works in your browser. So if you, I posted some links on the chat. So if you go to the playground, you can just try it, right? And it's interesting that in the browser, we're using something called Web LLM, which is like a local native LLM. So you can just literally do DSPy only in your browser. And that's crazy because there are like examples where you could use it for privacy preserving. Like everything you type into a text box, this little DSPy program will like filter it out before it sends it, and then put the data back in when it comes back, So literally it could be like an agent in your, there's so many things you can do. I know we're using web LLM right now, but there is increasingly work happening to put real models into like the Gemma 3N models. They're going to show up in Chrome. Like I know they already are there, but there are going to be models, in the edge everywhere. And, I want DSPy or AX to take advantage of that. Yeah, I think that's at a high level, everything I want to say about DSPy. The idea is, keep it small, use it everywhere. And over time, it's like there is going to be a lot of like, what's the best way to put it? But it's like your code, your programs, whatever you're trying to build, they have a deterministic part and they have a fuzzy part. So you have to be careful where you're plugging an LLM in. If there is a deterministic step that you can predict based on some information in the database or something, don't ask an LLM to try to make that decision. That's, wasting compute. Like figure out where there are fuzzy parts that you could never achieve, right? I mean, like if someone gave me a blob of text and told me just classify this like 5 years ago, I couldn't do it. I mean, it's set up a company for it. They're like, oh, let's have a team of ML people. And now it's like what? A signature, right? So you'd be surprised what these signatures can do. Like in AX, we have so many capabilities. We have the concept of multimodal signature. So you can have a type audio or a type image, a type file, a type link. And all of these map into the underlying LLM because in AX, everything is native. We have no dependency. So all the API stuff for Claude models, all the API stuff for Gemini, all the API stuff it's all native. It's all part of our code. We're not using their anything. Even streaming, not streaming, token, thought, all these capabilities, search, all of these are natively baked in. So it's only our TypeScript code, completely tested end to end, and it's vertically integrated. So it all works together. Like in AX, you can set a thinking budget on the forward options. You can say thinking budget minimal, and that maps to the underlying LLM, no matter what the LLM is. You can do the same with streaming. AX is also end-to-end streaming, which is sort of interesting because you can have DSPy output, the output fields, like be streamed out to you. So if you have an array in the output fields, you will get like the values in there as they're streaming. If you have a text string, you will get, you get chunks of it. So that, I'm not saying everyone needs that, but that's an interesting thing. Well, we have this thing called streaming field processor. So if you have an execution language that you can somehow parse while streaming, that allows you to do things like, early fetches, in a production environment. You don't have to wait till the whole code shows up. You can do sort of validation and parsing early in production. So even the streaming parsing that we have, the streaming asserts, they allow you to fail fast. So if something's along the way not right, you can eject, you can throw an error, assertion error, and you can basically, the LLM will try to, error correct. And now you're not, 2,000 tokens in, you're just like 50 tokens in, right? So there are several things we're sort of building on top. Caching, it's not something we're working on right now in an interesting way, because there are use cases in production. Lots of times the inputs are the same. And, you want to save, like GPUs are still an expensive resource. It's not like any other database API call. So yeah, so that's pretty much it. I think I've taken most of my time. And sure. The only reason I didn't is because sharing is still an alien technology to me. So I'm trying to figure out how. I'm not familiar with Zoom. So oh, there, share. Okay, I'm sorry. It's right there. Let me try. I'll take here. Okay, can you guys see this?
Yep.
All right, so this is, I've posted the link. You guys can see this yourself. This is an idea. I wanted to like, how do I highlight AX? How do I see people to get to use DSPy and try it really quick? So I wipe coded this thing. It was a DSPy notebook concept where the idea of DSPy is you have these signatures. So you see this is the, what I mentioned is the field name, the type, and this is a description of the fields. Not needed, but you can have that. And you can have, output field and the same thing. And we can try it with like OpenRouter, Web LLM. Web LLM is like, it loads an LLM like natively. So right there, it's ready to go, and we can try something like, user question, tell me a joke about, I don't know, DSPy. I don't know if it knows what that is, but we'll
That's
try
gonna
it.
be hard for Llama 1B. Let's go.
Let's try it. Okay, I guess that's funny.
What did you say?
So, and then you can basically like sort of chain the inputs. So you can take the output that's coming in and you'd be like, okay, assistant response, and let me put it into this and let me run it now. So the fields sort of like flow. I mean, anyone who writes code, this is not anything special. It's just taking the outputs and like, and now this is like, outputting Python code. This is all in your browser. It's pretty fast. So the idea is like, this is it. I mean, you can achieve so much with these little signatures that you don't have to. And additionally, it's easy for you to create examples because you know exactly the inputs, you know the exact outputs, and obviously you can tune and all that with it, but it makes it so much easier to just reach for an LLM. And if any of you are TypeScript people, like in AX, we infer types from this automatic string. So from the string, you'll automatically get a typed object back that takes takes user question as an input, and the output object automatically has responses. Honestly, I was never, that big a TypeScript expert. I was pretty shocked I could do this, that I could like chop up a string and build a type from it. And I guess you can, so we support that. So that's it for me. Sure, go ahead. Yeah, clear, loud and clear.
Sorry, the sound is not great. It's like big echoey. So Tarun's sound was great, but that wasn't. Yeah. Yes. Anybody around you? Tarun is very good. For me, is it good for you, Vic?
Yes. Yeah, thanks for bringing that up, Max. I was struggling to listen. So we support, stream because we also have to do streaming, parsing, and all of that stuff. It's not easy to just plug in any sort of typing thing like Zod, which doesn't support streaming parsing right now. Additionally, I'm not really a fan of nested types besides maybe a basic array. But if you want like an array of objects, I would urge you to make, n LLM requests, and you're going to get a higher quality output than just like asking the one LLM to do this. Or you could use a essentially you could use a function call, and you could capture the output of the function call. You define your schema in a function call, and then you basically get. There is no real way in. Actually, there is an advanced way that someone's contributing using like a dot notation on the signature to map to nested types, but it's still a complex merge that we're sort of designing to incorporate in. But the idea is I'm not going to move to JSON in the you can have JSON in the output. So there is a :JSON field, and we can essentially allow people to and you can add an assertion on it. So you can say this, you use Zod, you can add an assertion on that field and say, okay, this field has to be of this type. Otherwise, the Zod error then gets propagated. And so you can do it. But like natively, I am, trying to stick to the flattened output key value. And the two options to go beyond that or use the JSON field with an assert and just put Zod or whatever there, people have lots of opinions there. Some like some JSON schema library, others like Zod. So you can pick one. And the second option is you can just use a function call, and your function call can have a proper schema, and then it engages all the capabilities that they have to get your JSON correct. And you can even stop. You can say, okay, after this function call, I want to stop. There's an option for that. So. That's a good question, though. So it's a very common question because people just naturally are used to getting complex nested things out of software, and not I'm not saying that the LLM can't do that. I feel you're gonna like expense budget tokens towards that. Then it depends on if it's a simple extraction. Yeah, I mean the JSON thing should be okay, or but usually if it's a complex task, that you're gonna pay for it somewhere. Yeah, I mean, the same reasons why it's useful for hosted LLMs. It just makes it easy for you, in your code to work with these Gemma and stuff. And, you're not dealing with, like a low level thing like prompts, which is basically like, it's like working in assembly language versus, like a high level language. Yeah, but like a browser is an edge too, and my browser is not resource constrained. It's like on a whatever M series laptop with terabytes of storage. So edge, I know the edge word is like generally an embedded sort of system. I don't know enough about that. I guess I like Raspberry Pi can probably not run Gemma. I don't know, but to me the edge is mostly the browser. So it's most widely deployed edge. So. Was that a help your question, or is your definition of edge something else? Mm-hmm. Mm-hmm. I, I Yeah, the jury's still out whether those LLMs will like do the heavy lifting, or will OpenAI just call out to their own APIs, right? Like Apple is still struggling with this, which is why Apple Intelligence is delayed, because they're not able to get the small models to do everything they want. Because a lot of the model builders are not very good at building with models. They tend to trust the model a lot. Like if you hear all the conversation coming out of the model builders, they're like the model is God, right? And like when you're a pragmatic builder with models, you don't think that. You just think the model is a tool that does a specific task. You're not like, hey, solve this world problem for me, right? And which is again why you don't like subscribe to the whole like often people who are building with models don't subscribe to the doomer philosophies and stuff. So I think that these edge models will do certain tasks, and but the big models will do like more cool magical stuff which you're gonna need. So the edge is relatively limited. I mean, for now, I think I know Gemma 3N has like broken new records. I just don't know what kind of hardware you need to run that, right? I mean, it is like. Literally every one of the LLM applications, right? You're trying to automate. Like I would say that the best reason to use this framework is if you're a non-dev, you're like someone who's like, I mean, I wouldn't say non-dev, but someone who's actually dealing with the workflow, who deeply understands some process. Like LMs are great when you take like an expert at something real world with someone who can build and kind of put it together. They're actually not great if you just have a dev, because they don't really know what to build, and they all build the same thing, right? Like they build like I don't know, an LLM tracing tool, like like observe, like so. You really need someone with real world problems and he says, okay, this is what we're doing. We're getting these like emails from people, or we're getting these letters in the mail, and then we're like looking through for like the customer's ID, and then we have to look up this one database, and then we have to look up his policy and then check if he's allowed to do this thing and then charge him. Like this workflow is something you can just build with AX. I mean, essentially, right? And you could have that letter come in, have an image, and the image in the image prompt, and then you just use one DSPy to extract from the image prompt the exact information you need, and then feed that into a database, and then use the results of that database into another prompt, and you build this workflow out, and now, boom, you have this automated thing, right? Which is probably way more efficient, and you can keep evolving it. So there's, I think like a lot of things at a lot of workplaces can be fully automated. So yeah, I'm also convinced that the models today are very capable, and they could cause societal issues once they start getting deployed at larger scales. Like I am a big wipe coder. I use, I have Claude like in like 2 laptops running all day. I have Cursor as well. So, and it solves complex things for me. Yes, obviously it requires my inputs, but at the same time, I'm not typing or like getting involved with the boilerplate. It's building it for me as long as my instructions are, and if my instructions are of higher quality, then the outputs are way higher quality. Sure.
Gatineau, just
And I
next to
spent 2
Ottawa.
years in Toronto. Yeah. Fortunately, you got wasted with COVID and all that stuff. So.
Thanks. Also, first of all, I agree with everything Vic said. So that's it's everything is so true. So I want to reemphasize that. So what I wanted to start by saying is why I'm so excited about DSPy, like why I'm talking about it so much. And I haven't known DSPy for so long. It's been maybe 4 months now. And the reason is, well, first of all, I felt a lot of the pain of building stuff without it before, and so when I got to it, I was really thankful and it felt great. But then it's, for me, it's because of what it's going to be, what it means, what it shows right now. And so it's super interesting that Vic was talking about DSPy and why it's good, and talking specifically about LLMs, and he mentioned about small models too. And I believe that people that have experience with small models tend to understand the value of DSPy more. And I think there's something there that probably tells you how powerful it is. Is that if you are going to use a small dumb model because of cost, like in my case, I'm trying to run 100 millions of prompts in a day and to extract and classify text from big databases, and cost is of the essence. If we were doing it without thinking, it would be more than $100,000 a day. We do it for $200, $20. It depends on the situation. But how do we do it? Well, we do it because we use very dumb model and we just try to make them smart at this one thing. And so there's this interesting thing there. But more than that, what I wanted to say is that, so he explained very well why DSPy is good for a current large language model. But what I'm super excited about it is that I believe DSPy is showing the scaffold and the architecture of how you build any code with any AI part. And so it could be Dino V3, it could be Sound 2. Like DSPy has the right patterns, which I will cover and talk more about. But with the adapters, optimizers, instructions, fields, signatures, all those things together, I believe you have, like we have, and they have like traced the path for us of how we are going to build code that involved AI. And we want to build code that involves AI. We don't want to just use AI because there are some places it's just expensive and it's just more error prone. Computer works super well. Like we've been doing very good things with computers. And if you want to count the number of S's in a text, you should never ask for any probabilistic AI neural net in your life. Like you should never want to reach to that. You will want code. If you want to do if else according to a condition, you will want to use code. And so code is wonderful. Computers are wonderful, but there are things they cannot do. And deep neural networks, like generally, if we zoom out from LLM, works. Like we have shown that if you have the data, whatever you put in, you have the training set, we can make them do it and discover the pattern if the pattern exists. The recent demos of I'm forgetting the name, but the model that was released by Gemini 2-3 weeks ago, where you navigate through the world, this is mind-blowing proof that deep learning works. Same for, at this point, neural net, and with the mixture of experts of the LLM, anytime we run a prediction on the GPUs, we're using between 5 billion parameters to 30 billion parameters. Even in the big models, we're just activating some part of the parameters. And so at this point, we pretty much know that most things in the, like when we zoom in, can be done below, let's say 32 billion parameters. And so, and 32 billion parameters, if you quantize it a little bit, it fits on consumer device. And so deep learning works and can fit on consumer device. And programming and computers and for loops and if works and is super powerful. And we will want to combine both together. And I believe that DSPy has set up that scaffolding on how you do that. Because when you start to put deep neural networks into your if, else, for loops, functions, callings, and connecting them together, it can start to be very complicated because it's a probabilistic thing in there. And also, it's evolving fast. And so if you have your whole, like a big monolith of code that in one place you're depending for a neural net, you have some stuff that happens in your app, and then at some point it goes into a black box, because in that black box it was too hard to code, but the pattern was simple to discover. Out of that black box, you get your prediction. If 2 years down the line you want to change that because we have better architecture, we trained it, it can be smaller, different reasons. Well, if you build it with DSPy and following the philosophy and the patterns we learned through using it, and that includes Axe, you will know how to replace that piece, and it's going to be like the task of a day. And if you want to try, hey, is it cheaper? Am I going to save 100x today because I'm 2 years down the road? Probably. Like GPT-2 was running 2B models, and GPT OSS is running 5.6B. And that was like maybe 6 years apart or something like that. And like the difference in intelligence and usefulness that you get is outstanding. But if you don't build with the type of patterns of DSPy, you won't have any hope of replacing GPT-2 in your application with GPT-OS that just came out. And so, like, generally, those are my beliefs. Like, that's why I'm excited about it. And so I'm going to share my screen on kind of that visual of that. So you see the screen? Yeah. And so there's this kind of scaffold, this mapping of things, and I really believe that at some point we kind of stopped supporting, or the DSPy community and code kind of stopped supporting base model, and it's almost all instruct now. And like it's an adapter we're missing now, the base model. But we could have adapters. For an example I like to give is like Nano Banana. This week or last week, I saw someone post, this week most likely, about saying this, like show me an image of, or like an edit of a pizza cooked for an hour at 500 degrees, and the image was a burnt pizza, because that's the logic of what you would get. There's no reason, like in DSPy, we know how you would make a signature that your reasoning model would be Nano Banana making it burnt, and then you could detect that, and then you could, like, you know, have that type of question. I'm taking like a crazy example, but that's what I believe DSPy gives us as scaffold. If, let's say, 3 years down the line, the best model out there by 10x and cheapest is a voice model, you don't have to change any of your code that you've written today if you use DSPy, because the patterns that are used would make it so that an adapter will be made, and you will run another optimization, and you'll be able to do your input output with that voice model, even though you're doing everything with text, because we'll build connector to it, and it's going to be well integrated and abstracted away. So yeah, so those are like things that inspires me and why I'm excited about it. And so if I get closer to the details now, I thought I would like teach you that a bit more. And before I go into details of it, like, who's looking at that and they're like thinking, oh yeah, this is obviously, I know it, like I understand it, this is how DSPy works, makes sense, love it. Raise your hand if that's your situation. No, maybe one. You're all blurry, but I'm kind of getting an idea. Yeah, I don't know why it doesn't focus on anybody. Oh, that's good. That's good. You just need to move a little bit. So yeah, so like, who's looking at that and they are like, yes, this makes sense. Like this diagram makes sense. I know how, like that's DSPy. Okay, cool. Cool. So that's what I wanted to know. Okay, so let's go. Do you see my cursor? Like my mouse? Okay, good. Okay. So when you make a signature, you generally, the idea is, how do you give your intent of what is this function going to do, right? So you want to say, I will want to give some input to something, and I will want to get some output. It's like a contract, and I would want it to be done in some specific ways. But ideally, you don't go beyond the minimum that you have to say, because more can just be risky and confusing, because you may actually introduce contradictions, and also it's just inefficient. And so you want to give your intent. I am seeing 4 ways to give your intent. DSPy has not implemented them all, but I think with time we will. And like I said, the fact that we have signatures, we know that this is where the intent goes, and we know if we need to add a piece, we can. And so the main ways I see that you can give your intent is that you can say what will be the input name and its type, and the output name and its type. And that is often enough. And like Vic was showing a signature and he was saying, like, the description there is not necessary. And that's true. It really often is not. If you have your type and you have good names, it just works. So that is one way to give your intent. You can have instructions. And so that would be like just a small, paragraph description of the minimum type of instruction of what should be done, right? And at this point, that's pretty like standard DSPy. It's the beginning. And then you can have a data set. So you could actually, and I had a blog post and I did a little experiment that you could actually make optimization and a whole DSPy program just out of a data set. And Vic was talking about it at the beginning. That's kind of how it started. You were just making a data set, and that was encapsulating your intent, that you didn't really know how to put an instruction and you didn't really know, how to specify. But if you have enough example, you can kind of get at, I want to give an input and I want to get that output in that space. And they all work independently, and they can work and be more powerful together. You'll have a metric too. And so you could actually just have a metric or a judge and like kind of blindly search for whatever maximize it. And at some point you'll discover your intent, and you discover the program that maximizes your intent. It's pretty much a neural network. That's pretty much what they do. And so this is the part about the signatures, and I'm separating them because right now in DSPy, you're defining your input output fields, you're adding instructions, but so far that's it. We have talked with Omar about adding another field, and he's pretty excited about it. I think we just need to do it. We call it system field, where you can turn on and off the parameter. So it would be like, let's say you want to give a persona to in your system prompt. You want to say like, hey, you're a pirate. That has some sort of intent to like act like a pirate. You don't really know other words than say act like a pirate. And it could be something that's useful to give as input. And it can be useful to trigger trainability on it. And so that's maybe something coming, or it's an idea that can fit nicely into signatures. Then these two are here because currently those are the two that are optimized. When any of the DSPy optimizers algorithms right now, they usually try to write better instructions, which is one part of the system prompt. It's like plugged in a template somewhere in the system prompt, or it tries to find a set of demos, a set of few shots example that helps the model perform well. And all of those together are what at every call you will put into the LLM. And all of those together will be constructed into a prompt by the adapter. And you can have different type of that. You can want to build those things differently. Like you could want to do it all in a want the output all to be in a JSON format and extract that, or you could want it to be very free flowing, and then as a second step extract that, and that would be the two-step adapter. And like you could want to make it into a prompt template for the instruct models, or you could want to be like autocomplete and very base model like, and that's an adapter we don't have. That's one we would want. And then the adapter's role is to take care of putting that together kind of deterministically with code into a string that will then go into the base LM. And the base LM role is to go from is the only connection between the adapter and kind of the outside world, like the intelligence. And because of the way it's built, I was actually able in a day to make a library that adds a base LM that makes it so that you can use VLLM as an inference service, because I just had to like figure out how to wrap the inference service VLLM into, kind of give it the proper abstraction as a base LM to be connected and used by adapters. And so my adding a base LM in one day is the type of thing that convinced me that of this scaffolding and these like DSPy having the right abstractions in the right box and the right structure. Another thing that I was able to do, right, is the attachments library that Tarun has mentioned. Well, DSPy lets me kind of focus on different elements independently without worrying about the whole stack, and still coming in and plugging in and like contributing in one particular way where I focus. And so attachments is focusing on getting any string of anything, context like URL, PowerPoint, links or file path, repository path, and turn that into image and text. But generally, the idea is turn that into something that's LLM input ready. But And because the adapters were opinionated and they were generalized in the way that they take that, it was really easy for me to say, well, then I'm going to take any string and any path, will work really hard into make that a nice context for an LLM. And then I know exactly I have to only deliver it in one way in one place, and then I can plug into DSPy for any programs. And so attachments comes here and could plug here. OVLLM can plug here. And if some of you have seen on X, I've been talking and playing around with pruning mixture of experts. And we can then make an optimizer that would basically come here. Like we can make a library that you run your program, you look at your data set, you see which experts are activated, and you just change the neural net so that you don't load the experts that are not used. And I can see very easily how I could contribute that and how it could be used. And like I don't have to know everything about DSPy, because I like, despite this high level, I know very little about DSPy. I've basically written only one module of DSPy in my life, like the module subclass. And yeah, and so yet I know how I can contribute to it to make an awesome optimizer, very useful optimizer, and so on and so forth. And so the inference service then is the same thing. Like it's super easy for us to just, if we want to call Grok, we call Grok. If we want to call OpenAI, OpenRouter, like anybody, or if you want it to be local VLLM, you can, SJLang, all those things. That would be the inference engine. But you could have it be just your own code. Like it can be Llama CPP too, but it can be even like code you create if you want to. And then this inference will wrap up the AI kind of probabilistic black box. And so those pieces together makes it so that you are ready to, you can build them, optimize them, construct them, do anything to them. But then you can also plug it into a code base of deterministic code. And then the optimization on top of it, for me, it's like a little add-on. It's interesting and sometimes it's useful, and like some models are weird, and if you want to use small models, sometimes you have to like do weird things in your instructions or whatever. And so it's there, and it helps you swap the pieces, measure and everything. But it's to me, it's really about like these parts. And I really believe we can scale these parts also to non-NLM things, like putting AI in your code. So that's my kind of why and what I like about DSPy. I can show code of it. I can do different things. I can talk about attachments, or we can go on in code, or you can come talk to me, anything. Look, I'll start by saying I never used LangGraph and LangChain. And why is that I went to the documentation several times, and each time I looked at it and I was like, this is way too much boilerplate. I will code anything that I see there faster than all that boilerplate, and way too many things to learn. I don't like tools where I have to learn 100 function names that do each specific thing. I like a tool that has like a language and a design pattern and an approach pattern, and that's pretty much what I've been presenting here. And so that is the reason I'm like, I cannot even compare it, is that I could not even go through the documentation, but not because it's so verbose and boilerplatey, and I didn't like it. And so I preferred other approach than that, like Claudette Library and other tools at the time. So that's one part
I
can stop
I
there
can
for
try
now.
to explain that. I can try to answer that as well, if that's okay with you, Max.
Yeah, go for
So,
it.
so at a high level, I will say this: the DSPy is not a framework. It was a set of papers, a set of ideas that people are trying to incorporate. So, like AX or whatever, right, or the DSPy Python library, they're all just pure open source labors of love. There's no trying to sign you up for a service or, and that doesn't take away from anything, but the fact is that they're ideas that are like they evolve in research and they're sort of like evolving there, right? But I think Landgraph had some interesting ideas. The idea is that they want to capture a lot of like what's happening, the interactions that I talked about. I talked about this tree of DSPy calls, right? So you want to sort of that is a graph. I mean, let's just be honest, right? You can have if then else and sort of like code it up yourself and figure out, or you can put it all in some sort of structure, right? And that I did think about that, and which is like I'm experimenting with something called AX Flow. Again, not a service or anything, just part of AX. It is an extension. So remember, with the DSPy, I've always been building abstractions. So this is another abstraction of the concept that the original DSPy paper talked about at DSPy program. So in Python, how they did that was that they subclassed something and then they wrote a bunch of DSPy calls in it and they all registered it together so the traces would all be captured. But what if there was more, like, what if I wanted somehow to have a fluent API, which I sort of like, I like the dot, dot, dot. And so I was like, okay, can I build something which has its own signature? And then because there are inputs and there are outputs. So the whole program has a signature, but it's a virtual signature. And it sort of then gets mapped down levels into a bunch of other actual DSPy signatures and calls and sort of walks through and has some level of intelligence for common patterns that I've seen. Like I sometimes need to look at the output of something and then retry it if its quality is low based on whatever heuristics. I need the ability to make certain calls in parallel. But what if I'm not smart enough to like figure out which ones should be in parallel? Like it takes a lot of effort, right? But it's a huge, in a production system, that's a huge plus. And finally, I want it a clear, like an API that I can, because this is my high level, my final goal is to actually build, the final boss is like to build a model that will output DSPy programs. And this is not programs you want to persist in your GitHub or anything. These are like it literally, the model is thinking in DSPy programs, and the executions of those programs are generating new programs. So like that is my ultimate goal. And yes, models can write other language very well, but if I have like a clean defined API that can catch the whole compute graph, and I can tune my model to just output that sort of an API. And I can also give you capabilities like type safety automatically because I have an inferred signature. I have this concept that I convert the signature in AX does this everywhere. The signature automatically, there's a method called toFunction. Take the signature and converts it into a JSON schema. So now you can plug it in as a function call. So a DSPy can basically become a function call on another DSPy program, or an LLM. So I'm experimenting with something called AX Flow. You can sort of look at it, but at a high level, I am, sort of like in agreement that if there is too much happening and you're like, you need some like cloud thing to like orchestrate like this thing that could just be a bunch of if, while, then like calls, then I would stay away from that back box because, down the road, someone's going to like, it's just going to add unnecessary complexity. Right. So, like I'm more familiar with just code I can understand, or I'm okay with the library. Like, that's why AXFlow, I'm sort of like, even I've started to figure out where I need to use it because it's just a clear, simple wrapper library that I use in places just like I would use like a map and, like a reduce calls. So yeah, that's nothing against Lang tools or whatever. I've personally never used them because I've sort of had this AX thing in some version or the other way before, from before. So
do you mean, just so I understand, do you mean the like doing an optimization at inference? Are you using, or you mean the other way around, using DSPy without optimization at all and just doing inference with it and doing calls with it? Yeah, 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 yeah. Yeah, it's usually an orthogonal branch. I think just today on X, I was seeing a post on Databricks how they have this agent bricks that has improved with user feedback, and they show that they are doing much better than they if they are doing it continually through time. And so they do run an optimizer kind of sequentially through time in their chat Databricks agent. That's quick what I saw, and I know more and more people are talking about that. And when I was playing around with MetaKey AI, like a way to run the DSPy uh, programs on your clipboard, I was thinking about this idea that you would thumbs up and down a completion, and you would probably want to re-optimize it based on your feedback every so often. And so I believe that if you do use DSPy, it will happen in the future, that because you'll like your mindset will be set up for a training set, you'll be set up, like your pieces will be right and at the right place, that you'll be like, hey, let me just collect the training set and the usage, and then you will just optimize it. But I don't even think you need to plan it that much, because the patterns are good. Yeah.
I mean, it's just a function, right? It can I don't. It's so early, right? For all you know, someone comes up with a interesting idea to run it inline. Maybe if you're ready to wait for a while, but you want the best answer, like, maybe there's a inline persisting optimizer. I mean, no one's tried this stuff, but I think, like, it's all fair game to, like, it's sort of inference time scaling, right? All of this is inference time scaling. It's like it's your chain of thought. What is that doing? It's sort of optimizing, and then throwing away all those tokens. So you could basically build something like a DSPy MIPRO optimizer that runs inline. I've considered it. So not for production, but for experimentation.
Just so you said about the pruning, right? Yes, yes. So basically, what I played around, and it was just one day, very early. I'm convinced of the measurements I did, uh, with quotes still. Basically, is when you have a DSPy program, they are kind of by definition task specific, because you have defined an input and an output, and you have a training set usually, because you want usually to optimize or at least measure. And so given that, given that you're by definition going to be somewhere within the capability of an LLM, and usually you're going to be quite a bit within, and also you will already know how to measure that a bit. And so the idea is just that you would take your data set, your training set, and it would be like the Bootstrap fine-tune optimizer or the GRPO. It would be one that, the model has to be hosted. Well, no, the model doesn't have to be hosted, but it can be quite interesting to do it on very big MOE models. And so if you want to do on big MOE models, you may not have it on your laptop, or you will want it to be an API hosted somewhere. But you could spin up a prime intellect machine. That's what I did. Set a model in there, run through your data set, and just track each expert measure, like used at each layer. And at the end, you're like, hey, there are 20% of the experts I never touched, and I feel my data set is representative. Well, then you can, the code doesn't exist yet, but you could have the code that makes it so two things. Either you save that architecture without those parts, and then libraries like VLLM can host that prune thing for you. There are complexities to do that. Or the other thing is that you do another library for inference, similar to VLLM, that just loads what was shown to be needed. So you don't touch the architecture. You're still calling it from Hugging Face, but you're loading only the experts you needed in the VRAM. Is that in words you were interested for the response? Yeah. But the thing is that you wouldn't, to me, to my understanding, you don't change the router. You don't actually change the architecture in my preferred way I would do it. Like, let's say you could even just go remove them from VRAM, but you don't change it. It just happens that when you go through the router, they don't go there and they don't route it. So it doesn't matter if it's not there. It's like if I had a code base where in somewhere in my code base, I'm going to call a database of a terabyte, but I just measured that with my given users, they never go into that branch of the code base. Does it matter if I delete the database to the code base? No, it doesn't break the code base that it's not there. It's just that if it was to call it, it will break, but it will not call it because that's what we measured that it doesn't do. Oh yeah. Yes, yes, yes. This is true for sure. And you would probably, like in my mind, you would be that would be in scenarios where you're okay that, well, you do things right. You route to a full thing, maybe an external provider. If you're going there, you kind of capture that signal. You measure the router, and instead of doing the actual computations, you're leaving it, or you're actually loading it if you have the place, and then like you could do different strategies to handle that, but for sure there are complexities. um, this is super, like, this is just an idea and it's super early. um, but I measured it with R. Like, I asked a lot of specific questions about R coding to Quen 30B, and it was activating only 40% of the model to what I measured. And my idea is like, maybe I would need 70% to feel pretty good. But 30% less RAM, if it goes from 100 to the 70 gigs, that can make the difference between running it or not, depending on your hardware. And you can have bigger batch size, and it depends on the use case. Then it's just about finding ways to capture that, which are in theory possible, I think, but it's super early. I mean, the reason I did it is just I didn't hear about it and I wanted to know, but I'm not like, I'm no longer doing a lot of neural net training and architecture stuff. And so I wasn't, yeah. Thank you. Yeah, that was a pain to do my own adapter, and I'm talking about it with Omar, Azak, different people. Like where I like adapters, but the way of coding them to me is wrong. It's not yet fully fleshed out. I think it can be more declarative than it is. So it was hard. At the end, the easiest solution I found was, I think it was Omar at some point, he gave a suggestion, was to basically just, instead of implementing some method and the format and stuff, he told me, was like, if your adapter is taking in those 4 things and calling base LM, you're good. Just do anything you want in the middle. And that's, I can show it to you. And that was what I played with. Let me share it. We'll get into some coding at the same time. So, so I have a blog post about this with code, and so you can go read it. So I will go fast on some parts, but basically we have an example set, and I'm generalizing it. So it's prompt and generation, and that's English stuff, and that's French Canadian stuff. So it's a translator we're trying to make. A dumb metric here is to just measure French words to see like, hey, let's maximize French words so we know it translated. A good metric is to have an LLM judge that says, is this French Canadian stuff? Then we do an empty signature. So I'm just kind of going through that so that you get what's going on afterwards. But basically, right, if we, and then I'll try to talk to everyone. So, oops. Is it big enough for everyone, or do I make it bigger? It's good. Okay. So that's kind of a very empty signature. But then that was my point, or my problem at the beginning, and I know some people have the same problem with DSPy, is that the adapter is still there and quite opinionated in its style, and maybe it doesn't work with a funky LLM you're trying to do. And so, right, because my very empty prompt is generating all that. So the actual system prompt that Kimi saw is this. Like, it filled in the prompt from my prompt above in the signature. It filled in the generation from my signature above, generation. So here we have both at the same time. So prompt was here, and that's why it's here. Generation was here, and that's why it's here. And then that sentence is baked into the adapter. What I'm thinking we could improve is that we could make, let's say, those tags, we could make that a place where you declare those. This sentence, you could make that a place where you declare it. This style of setting that, you could have a place where you declare that. And then the way that you deal with the image inputs and the identic stuff, you can also have a place where you can declare your own function to transform that. And so say when we worked on the adapter that does more of a BAML style translation of a pydantic translation with the tech optimist, and it would have been easier if we could have just provided that one function, right? And so I'm imagining that there may be kind of 20 elements to an adapter that from which the current adapter is built, and that you could declare those. And at the moment you can't. And so at the moment, like, let's say like that's this very, very empty vanilla classifier or signature would give you that. Then the actual prompt would have the square brackets. You will spend token there. And my first gripe with adapters as they are with other custom adapter is that I was telling you before, I'm running, like, I want to run 100 million prompt. Every single token costs me something because it's 1 million times that token, right? And so I don't want to have to create a response where I have to produce those tokens. I'm asking yes, no questions. I will have 10 times many more tokens to produce than a simple yes and no. So I need a custom adapter to control my output to be just yes or no. I need a custom adapter to not have tags if I don't want to, and those type of things. And so, but that current adapter does that. The advantage of this one is that it works super well very often. And so if you're not like kind of, at the scale I'm trying to save my tokens at, they are there for you, like they protect you, they do very well. I'm right now working on a blog post about optimization, and I wrote a custom optimizer, and I measured also the baseline call and then optimized call and everything. And the base call from DSPy is as good as a base call you do with LiteLLM or whichever other library with your own prompt. Like it doesn't hurt generally, this adapter. It just costs tokens and has been made to be robust more than other trade-offs. And I don't believe that we will, at the end of the day, always have the same trade-offs to do. And that is also kind of coming back to my other point about the scaffolding. What I like is that if you're coding with DSPy, and it just so happened that your thing is that you actually really like, you have your problem, you're building your thing, and to really make it work, turns out that the solution is that you need to change the model's weight. Well, you can go do that. And some other time, the solution is that you really need to present the prompt differently or to extract the output, to parse it differently. Well, you could go do that. You can go do a custom part at any part. You need to inference different. Maybe I'm creating the new Grok Q or Cerebrus, and I want to do my own inference, and I want all DSPy to call me. Well, I can make it and plug into DSPy. And so then if I continue now, like really to the adapter part, what I had to do, and that was it. Like this is the simplest custom adapter I could figure out to do. And if you decide that your adapter does not support demos even, that would be it. So basically it's how do you turn, you're getting past an LM object to do the LM call. Like that's a base LM object, it has to be base LM. You're getting past arguments that you're going to give to your LM. You're also given the signature, the demos, and the inputs. And you do whatever you want with those. You can ignore them if you want. And so I decided that I would ignore demos, let's say for now. And I am not ignoring input, but I'm actually hard coding that the signature will be prompt. Because in that case, I was like, I don't even let you have your own signature. And so that would be the simplest adapter. And if you do that adapter, one thing you need to do is you need to subclass DSPy predict, because if you set that adapter at the level, like global level for everything, you'll have the problem where now your optimizers and everything else uses that adapter, and then everything breaks because it's too simple. But if you want it to just be for your program and your call, you'll just subclass and do a forward of the predict. And so then if I do my predict around the simple empty signature, and I've given my simplest adapter to the context in that predict, then I can use that program. And now if I use that program and let's say I optimize here without Bootstrap demos because I'm not supporting them anymore. And so if I'm just running that optimization, then afterwards, I have given no prompt, I've given nothing else than the training set, and now I have a translator because MiPro read my training set and figured out that it had to make a prompt to say to translate. And if we look at the history right now, you'll see that I just had the system prompt written by the LLM, my text, the output. That's it. And that was actually a very funny optimization right now. Not as much as the police thing, if you've read it. That was the tutorial where I had this police thing in a convenience store. But Kimi sometimes comes up with some pretty funny prompts. Anyway. It does it. Let's say it does it a little too much for now, but like that's like the I didn't like it's a made up example to I find translation makes it easy enough to do the complete things. And so in these example sets, so it's just it's those 30 examples, and that was enough to get the instruction you see below. But those were already quite kind of really heavy French, like some of these things, like we were sure we had something about blonde and then fret, and like so it's not it works great, but it's quite heavy street Quebec French, let's say. Thanks. Thanks. Yes, I'm staying around, so if you just want to come and chat, I'll be here.
Max, are you from the Plateau, that neighborhood?
No, I'm from the countryside. Grew up on a farm.
Okay. Because
And,
I've been to that neighborhood as a tourist and loved it.
yeah, well, it's very classic one, and I'm. It's been the second time that Kimi mentioned it. It's very
Yeah,
funny.
I used to drive over all the time in the summer when I lived in Toronto.
Nice. Yeah, well, Montreal is a nice city. Yeah, I've never been to Toronto. I've been around it, but never in. Does anybody call you Spacy in real life?
Yes, a lot. People, I'm not anonymous technically. I'm just pseudo anonymous. Just so
Yeah.
no reason. I forget where the like people call me all the time because they are like, oh, is that your name? Do you want to be called that name? They get confused.
Yeah. Well, I was gonna
I'm pretty
ask that.
public, so it wasn't a anonymous thing. It was just
Cool.
online. You can be anything you want to be. So
Yeah.
I was like tired. I was getting a little tired of the fact that everyone's forcing you to put your real name out there.
Yeah.
No, I was just all these networks try to force you to put your real name and identity, and I'm like from an era where everyone had handles, and so. Oh, really? Sure. Yeah. No worries. No
Yes.
pizza for us,
Perfect.
I guess.
Perfect. Awesome.
So where are you based now, Max? Are you still
Now
in?
I'm just close to Ottawa.
Oh, you're
Just
close to Ottawa.
on the Quebec side of Ottawa, basically Gatineau.
Okay. Yeah. I know
You
where
in
that is.
BC? Are
I
you
am in
in
BC.
Vancouver or?
I'm in Vancouver. Yeah, downtown.
Cool.
Yeah, I was always I used to live in the Bay Area, like Silicon Valley for like 10
Oh, yeah?
years. So I'm mostly a West Coaster. I think Toronto was an experiment. It's a great city, but I miss the mountains and the ocean and the weather here. So
Yeah, no, it's the better is the weather is much better over there. Yeah, definitely. I've never
have you been to Vancouver? No.
Vancouver, yes. I've been all across Canada.
Okay.
But I skipped Toronto. But never been to San Francisco.
Well, it's not far from here, so if you come, you should do Vancouver and San Francisco sort of things.
Yeah, nice.
It's nice to drive down too. It's not that far. It's a beautiful drive if you want to go through.
I met a guy that
Seattle
did the biking all on the West Coast, and he was telling me about it, how beautiful it was. Yes.
I'm a bike
But you're
person as well, so I've
I was
not had
gonna
the
say that's right.
Yeah. I'm
You
not. I
talk about
I
it.
don't have the guts of doing that. Some people are trying to like convince me to do all the way to Seattle, which I think I might. So
Nice. I cross Canada on my bike, so I'm also a bike person.
okay, wow.
That's how I
is
saw
impressive.
Canada, and then that's where I met that guy. That guy was telling me that he crossed
That
Canada
is
with
cool.
me because we met at some point, and so we continued
Okay.
together, and he did the West Coast and stuff. Yeah, so biking
Yeah,
around
you should post pictures of your bike sometime.
I don't bike anymore actually. Well,
Okay.
I own a farm, so I'm on the farm right now, and so I'm quite sedentary or moving on the farm instead of biking. I had not used my bike with which I crossed Canada. Then I used like for 3-4 years, and then I went to Ottawa with my son, wanting to do a little bike trip, and my chain was so rusty that when I pushed hard, it just broke, and so now I
Oh
need to
wow.
replace
Okay.
that. And
That can happen if you ride across Canada with it.
Yeah.
Vancouver is a great like biking city because I mean technically in the winter you can still like bike. It rains a bit,
Yeah.
and it's got a lot of protected bike lanes. Like my kid like travels through the whole city on his bike.
Nice.
So
Nice.
they've put a lot of effort into the bike lanes, and we have this beautiful seawall.
Cool. Oh, it switched to
So what are
the
you
screen.
working on with the DSPy mostly? Personal projects or?
So really, like the way professionally, the way it came to me is that I was where I'm okay. So where I'm working, we're trying to classify the scientific literature into domains of science for the whole of scientists of the whole scientific literature. So we often get asked like, can you tell me how good I am at Arctic research or whatever? And so to do that, we need to know what is the scientific publication on Arctic research. And there exists no like just kind of, there's no flag that tells me what each papers are about in the world. And so 5 years ago, I did a neural net custom just for that, but just for one taxonomy. And otherwise, we would build very, 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 very big SQL query for matching words in the abstracts. And so when GPT 3.5 came out, I actually tested it against the neural net I did. I was like, oh, it's as good as my neural net, but now it can do any taxonomy because I just prompted taxonomy. And then I started to see if we could use it, but then I was like computing that it would cost $400,000 to run once. I was like, oh, that doesn't make sense.
Yeah.
And then the rate limit, right, and stuff. And so then Llama Llama came out, Llama 3. And then maybe a month after, I self-hosted it with just PyTorch, removing the for loop because I was doing like a one token prediction only and making all the batch equal and like optimizing it a lot. And then with that, I was able to run the whole literature for maybe, I think it was probably around $10,000 then. So I was like, oh, that's much better than 400,000. And we were happy about that. And so we used that a little bit. Then VLLM, I learned about it. It got more stable. So I ditched my custom implementation, started to use VLLM. And then I started to be at the point where I realized that I kind of understood a little bit language models, and that I was doing a lot of things to prompt it and have confidence that my prompt was fine. But then I was getting all my colleagues to start to use it, and then they would run a whole inference for several days, and then their prompt was just really, really bad. And so it was actually for me a way to be kind of in between the user intent and the actual prompt for the llama. And it was also at this point I was like, well, you know what, guys, we're running millions of prompts all the time. Maybe we should just check how good they are, and like if we can make them 5% better, why not? And so then I started to look into DSPy for that. And so one of the things I really like to do is that we use a SOTA model, like just any SOTA model, because we accept that they're good enough at classifying the scientific literature. And our goal is that's our training set. And our goal is always like, how small can we self-host a model to mimic the output of that? And so that was the first thing. Then I got into also like a PDF XML extraction pipelines, and then also at home I made
strangely enough, I started on DSPy and stuff, and even my work on EX is because of papers as well, because I was building a startup called 42papers.com. It was like I was trying to basically, archive was blowing up around then, and I was trying to extract like insights from each paper to sort of like and make it relevant to you, so you could sign up and you would not see the whole papers, but you'd see insights.
Nice.
And this was and I was using these BERT models trained by Allen AI tuned on archive. So
so one of the tricks we use to not run on all prompt actually is that we use Spectre from Allen AI. It was our embedding before other embeddings came out, and so we embedded all of the abstracts. And so we first do a cosine similarity, and if the abstract is far enough, we don't even consider it, and then afterwards we classify with LLM.
I used to do similar stuff, but only for archive.
Cool. Yeah, so I work for Elsevier, which has 30% of the scientific content. So
I know those guys.
So we have the whole database, and we process the whole database scale and PDF extraction too, and now and then but actually the first time I explored it was in the weekend, because I heard about it too much, and I was like, okay, well, I read about it and I kind of put it on my list of things to go for the llama thing. But then when I went on the documentation and stuff, one of the things that I was disappointed and like stopped me for a long time is that I didn't see how I could, in my Python process, use my VLLM code, because it's not an inference engine they have. Like, you can do the API call, but that's not how we are set up. Like, we just have like this server remote and stuff. And so I was like, how can they run optimization, which is a database, like a multi-batch infer? I don't get it, blah, blah, blah. But then I had built a pipeline to try to do my extract my invoice for my incomes, and like taxes, tax amount on each bill and invoice total and stuff. And so the first year I tried to do that pipeline, I did it with Claude 3.5 maybe. And I had 4 files, 500 lines of code to do the parsing, like then the image, then rotation of the image, pass it. Anyway, the whole thing super complex. And then the second time around, I was like, let's just try DSPy here. And then I had kind of started to play with attachments then, because I was like, getting images to LLMs is a pain. And like, I hated the JSON. I still hate the input JSON message format. I think it's just ridiculous. I don't know. I hate it. And so I wanted a way to get the context nice into it. Did it with DSPy, and the whole thing was 58, 60 lines of code. And my previous pipeline was so complex, I didn't measure it. You know, it was just like, I kind of work,
Yeah.
it seems fine. Like at some point you kind of get so far that it's like, you cannot, like, it's so noisy and like hairy that you don't know what would be your measurement, your training set, blah, blah, blah. I don't know why, like it just doesn't feel the same when we do it with signatures. Your order, like it's clear, your training set is clear, and you kind of just always want to evaluate it. It's like so easy. Yeah, anyway.
Fair point. Yeah.
That's
So how often do you use optimization? Like, do you reach out for it all the time, or do you now just play with big
no,
models?
I even still with small, like, okay, so today I was extracting references of PDF, and I tried Llama Scout, Llama Maverick, and they were all, everything was 100% without optimization, right? Or like 100% on the things I cared about. And so I didn't even optimize. It was just like, and also it's because I write the code with Claude, right? Claude code and whatever. And so I give it all my code. I give it my Excel files. I give it the PDF. I use attachments to give it a little bit of examples. And at this point, Claude writes a good instruction,
Yeah.
right? And so my instruction is already good. And so often, yeah, I don't need to.
And even the smaller models, like I've been playing with the Gemma 3N model. This is really tiny multimodal model, like
Yeah, the
from
4B,
Google.
Gemma
Yeah,
3 and 4B.
I think so. Yeah, it's
Yeah, I
called
played.
3N 4B.
Yeah,
It's
I played
it
with that
does
one too.
everything without optimization. So
No, exactly. And this one I did the same. So I tried to do, I was working on extracting and labeling captions from Hugging Face, and I used Kimi, Quen 230 something, and Maverick, and I decided that the truth will be the 2 votes out
yeah.
of the majority out of the 3. And so I did caption extraction of those with them. And then after I was looking for, I'll do an optimization for like Quen 4B or Gemma to get the same result. But Gemma was just getting the same results, no optimization. There was one of the 3 that I needed it. And the 2 other ones were just the vanilla instruction. And it
Crazy
just
how
worked.
good these models are getting.
Yeah, it's amazing.
So do you have any, like, I don't know, opinions about AI outside of just like DSPy and the future? Do you have
Yeah, I really believe that it's gonna be like a big sea of fine-tuned model, specialized model. It just like
So what happens
most
to the
things.
economy?
Oh yeah, well, it depends how you implement it, but I'm quite happy. I'm not worried. I'm not worried.
I mean, adoption is slow. I would say that
Yeah,
most people don't know how to build. I like part of my thing with DSPy is I feel I'm like helping people just build. That's why I don't even go into
yeah,
the advanced parts. I'm like, let's just start picking this
yes,
stuff up.
yes,
Like
yes.
I do travel to Silicon Valley a lot, and let me tell you, most people in the Bay Area outside of SF, they don't even have a ChatGPT subscription. So they
Yeah,
don't know what's going on. People are like vibe coding, all that. It's too far out for them. So even if the so-claimed technologists
yeah.
haven't yet come on, their managers are scared because they think if they are, if people are going to be replaced, then they're not going to need the manager either.
Mm-hmm.
So there is a lot of like humans sort of like quietly slowing down progress.
Yeah, they do. I mean, it's gonna be different, and there is so much to build. Like I often say it, like if any advancement in LLM stops now, we still have like 20 years of things to build to use them and
Yes,
like
I
advance
agree.
anything. Um, and when we're done with that, it is going to be very different. I really think the humanoid robot have enough now to happen. Like I don't think there is another breakthrough that's needed. It's just work. And once those are there, then it can start to be different, but it's not going to be that fast. Because when I think about it, like you can go crazy if you think like, oh, humanoid robots are going to be there, then they can replace everything. But I think about it like I think about compute, like heavy compute and big data and those type of things, where you're always like thinking about how you're gonna distribute your task and like what is the bottleneck, and like things are always not fast enough for us, right? Like computers can process databases very fast, and we still are like, oh, this will take 2 months of compute, right? Even if it's not LLM stuff. And I think humanoid robot will be the same thing. It's just will be about allocating robots time as you allocate compute time. Like, am I gonna use my robot to drive my tractor, or is it gonna be to build a table, or is it gonna be to build another robot so then I have two? Is it gonna be in parallel? Will I give them a tool that is very expensive so each robot works faster, or will they not have a tool and then be slower? Like there's so much thing to do and build that there is still so much value and decision to be made, and optimizations for different businesses. I come from studying biology. Like I did all my studies and graduate studies were in biology, and evolution and species. It shows that there are billions of ways to do something optimally, or to pick a niche, or to approach problems and to have your place in the world. And even though like everything is solved, if you think that will happen, there will be still that many places. If you're not trying, you're gonna probably actually a better time anyway, because you're just gonna benefit from everything. Anyway, long answer, I guess, to my rambling to your question. And what about you?
Yeah, I'm completely agreement. I think that even if we stop now, I think we have like there is like we can still change the world. I mean, if everyone starts adopting, these things are good enough. I mean,
Yes,
yeah,
yes.
and this is I'm talking about like practical specialized things. It does even if they cannot do advanced math or can't figure out new math. So I'm also of the opinion that smaller and faster models are smarter models, sort of, because you can run them a lot more, you can sample a lot more, you can I think the bottlenecks for like the next gen, whatever they talk about, like inventive AI will come up. I think the bottleneck is mostly verification. So like in biology or something, when these things start getting connected to automated verifiers, like code is the easiest to verify. So we got like the
Yeah.
furthest with it.
Yes.
So
Yes.
once we start getting better verifiers for other things, the other things will like move up really quick.
Yeah.
And smaller, faster models means you can like sample a lot more. I mean, you could be bottlenecked on the verifiers, but I think we have the recipe to even more greatness. I think we just have to, apply it.
I think there is a lot of also there are still some problems that are not about unsupervised training. There are still some things that are supervised training. There was actually this interesting release 2 weeks ago about bird songs from Google, where they still used a supervised approach, and they were part of their paper was saying about how some things are just better to be supervised. But the interesting thing is that I believe that some stuff that has moved ahead because we found how to do it with unsupervised training will help collect the training set. And so there are a lot of things that you just need a training set. Like I really believe with deep learning, you just need a training set. And now maybe you will use an LLM with neural net, with this and that, with
You think we
strategies.
can we
Maybe
can talk to cats and dogs?
this, I don't know. I mean, if we can we can clearly communicate better with cats and dogs. This I agree, because they can communicate, and so there is a pattern to detect. If there's a pattern to detect, it's detectable with neural nets.
Yeah.
Yeah.
I mean, a lot of the things we do, I think humans tend to like accrue this thing to it, like, oh, this is us doing it, and this is our creativity. When it's really there are just patterns that can
Yeah.
be learned,
Yeah.
And even creativity is just based on like patterns you have internalized over years from other sources that have created those patterns, who've also internalized them from somewhere else. I mean, the whole world of papers, right? It's just it's research based on research.
Yes, I agree. Yeah, no, I'm not. I don't think they're magical, but I don't think they're useless and it means nothing. And they're,
No, I
like
think
I don't
I
care
think
that
they're
they don't do.
world changing, and I
Yeah,
think the magic is in that
yeah,
itself. Doesn't have to.
yes, I agree. I yeah, fully agree. Fully agree. Yeah. No, it's fun stuff. I mean, it's just fun that we're doing like that. We live that. I think that's.
I know. I'm so glad to be here right now. I mean,
Yes,
like
same.
yeah. When I'm not even writing that much code now. I honestly, a lot of my code is written by AI. I do instruct it, but then I'm not like in the weeds with the keyboard.
Yeah. Well, you got me into trying Jules and Codex and this type of approach because you were talking about it, and
Yeah.
you're actually, I think, on my timeline, you're probably one of the one that shows at least that you're pushing it very, very far. I think I'm pushing it further than a lot of people, but yeah, you're some things you say, and I'm
I think
like,
we're
damn,
very new.
I gotta
Yeah.
connect things more. I gotta starting more things. Yeah.
I honestly, I am able to have like 100, like you should see AX, like I have like 5 releases a day when I couldn't get one out in a week, right? I mean, there's so much boilerplate. I'd be like, okay, you know what? I'm done with this stupid test system. I want to migrate it to this test. Just do it, right? I mean, and then
Yeah.
when you clean up these little things and you start like getting the AI to fix the foundations of whatever tech debt you had, you start
Yeah.
moving faster. So, okay, I want documentation. I want this. I want a AI documentation that AI can read. I want you to start reading that documentation and writing this piece. It's also building on layers. And when you sort of approach it that way, even when you're like building, okay, I want you to build this API to do this. Okay, fine. Now I want you to use this API to do that other thing. Make sure you've added tests around this API. And now I want you to use these. It's sort of like you keep building domain specific languages and getting the AI to sort of keep using them and then build the next layer.
Yeah.
And as opposed to just say, do the whole thing.
Yeah. I believe a lot in that, and like um like libraries will be more and more important because it's a way that LLM can do more in a tested way with less tokens. Because if they can call one function to do a thing that has been tested and built, they are suddenly cheaper and more reliable to do that thing. And so libraries are more important, but at the same time, they're not trained on new libraries. So anytime you want to do a new library or use a new function, it's always a bit of a trade-off. Like, am I gonna fight with them all the time about getting them to know it right and
Yeah.
use it right? And there's less human that are gonna use the new libraries because they're gonna vibe code. And so like there's this super weird, ironic, paradoxical situation with libraries and like levels of abstractions right now where they are the most important thing to really like robustness and price of LLM, but they are also the hardest thing to use with LLM.
Have you, so what are you using? Claude Code or Sonnet or Cursor?
I'm moving a lot these, like I don't, so there's my like personal setup and there's my setup at work. My personal setup, last month I decided to try all the Revius Pro to kind of compare them. So I had Cloud Code, Grok Heavy, now Deep Think, and and ChatGPT before it was bad. No, I don't know how you feel about GPT-5, but so far I'm not as happy with it. But
But
yeah,
have you tried it with Cursor? It's really good for coding. I think it's
so I
focus
left
level.
Cursor. I used Cursor for maybe 3-4 months. I was using the agent, and like attachments was done with mostly. I did attachments mostly with Gemini 2.5 in Cursor and agent, and that was nice at that moment. But I started to be frustrated with Cursor because I felt I just didn't know when it was giving the context or not. I was starting to kind of lose control on the prompts, and I didn't like it. Like, because I didn't feel I could steer it like I wanted. And so now often I'm doing like I'm working on kind of a clear prompt, kind of collecting my stuff. Then I'll give it to all 4 SOTA model in the chat. They'll produce something. I'll merge it all together and give it back and say like, here's the 4 implementation. Now do it in one well that you're inspired by the other ones. And
Oh,
then
so
I
you're
would
building
bring,
your own thing, essentially.
yeah, I'm
Using
kind
the
of doing it by
APIs,
hand.
not the, oh, okay.
Well,
There is some value in their like search APIs and stuff that they have, like the indexing that they do over your code and stuff that makes like cursor and stuff like a good
of
option.
cursor, yeah. I had done a library a year ago now, where it was. Do you know about Jupyter notebooks or not? You're
Yes,
not
yeah.
much, yeah. So I built a library a year ago that it would give me a magic function in the Jupyter notebooks where I could do %sign user, and then I could write anything there. And if I was executing that cell, it was sending a chat to whichever AI I wanted with the context of the code executed in the notebook. And then the AI response, I would parse it where the markdown would be in markdown and the AI code would be in code chunks. And so then I could just execute the code cell, and then it would do things on my computer. And so a year ago, I was using that a lot, where I was often asking, like in notebooks, I would be like, hey, can you go things like, can you reformat that video from, MP4 to something else, or can you like increase the speed? And then Sonnet 3.5 would write a Linux command, and because it would do code chunks with the shell, I could turn the code cell into a shell cell and execute it, and it would like act nicely on my computer. And so I was using that before the cursor was kind of even around like that big, and I really liked it. It basically is now Claude Code, like it's the same value,
I see.
I would say. And I use Claude Code now, but I'm not happy with I'm not yet happy with what's out there personally. What's your favorite setup?
I have a paid, so there's like you have to be sure you're using the Opus model and the Sonnet models like together. Opus does some planning, and then so Claude Code has mostly been good for the stuff I'm doing, like but at the same time, when I need more like control and I'm doing more like precise things, if I'm doing like giant, like trying to like write documentation, write a bunch of tests around something, like bulk work, Claude Code is the way to go. If I'm doing more surgical stuff, then it's Cursor.
Yeah.
With and recently GPT-5 was free for a week, so I
Yeah.
jumped into it. So I don't know whether they've now switched to a quantized model or something, but the GPT that we got for free for the first week was amazing. It
Oh,
was
yeah.
Opus level. It was Opus level, and it was like it was 1/10 the cost. So
Nice,
um,
nice.
but outside of that,
Yeah.
I'm not like a OpenAI user directly. I mostly use Gemini, which
Okay.
I
Yeah.
like a lot. So they're really good, but I'm not confident as like I found the Gemini coding thing to be like very good, but I found some of these to be better, like those.
I I think what I'm seeing with comparing the four models always and kind of merging their answers and stuff, like I should say, for a while too, I was using OpenWebUI a lot too, and where you can call all four models and merge the response in the user interface. And this is kind of where I got hooked with model merging. It's
Mhm.
always better to put the four models together and tell them, here's all the ways you can look at it
Yeah,
and
yeah.
do it one better. And so I kind of got hooked with that. Um, and Yeah, so I really like merging, but often now I launch them all, and what I realize is that it's really domain specific. If I work on PyTorch, it ends up being one of them that's like outstanding, like clearly better than the other ones. Like all code run one shot, and it understands everything. It just works. It debugs it super well. The other one struggles, do dumb stuff, invent something doesn't exist. I switch to something else, like then doing like PySpark, Databricks, data manipulation. Then it's another one. JavaScript, TypeScript is another one. Like I really find that um, and that they are different. And I think that's why people would disagree so much. Is that some people are coding in C++ and they will just say that Model X is dumb, and that's probably true that it's worse in C++ than
Mhm.
another one. I think Claude and ChatGPT seems to be better in TypeScript
Mhm.
and JavaScript, I think, than
Yeah,
Grok.
that's possible. You know what? And that, like, you're Python mostly, right? Though.
I don't like Python, but I'm now
Okay.
Python mostly. But I'm from R and Julia.
Okay.
So,
Probably the
but
least
now,
amount
yes.
of training data out there on those. So.
Huh?
Probably the least amount of training data out there on Julia and.
That is one of the reason I'm with Python now. It's like I was tired of fighting the LLMs to get
Sure,
them to
yeah.
do Julia stuff. You know, like in Python, you ask to do the thing and the code comes out in the language you expect. When you're in
Yeah, yeah.
Julia, don't forget to always say it's in Julia, right? Those
Yeah,
type
yeah,
of
yeah.
things, and then
You
it's
probably
just not
write
as
it in
good.
Python. So.
Yeah. So no, yeah. Now I'm in Python because
Yeah,
of that. But
TypeScript definitely helps because it adds a lot of like context just
yeah,
naturally.
yeah. But I just don't like the syntax of TypeScript. I have a hard time with its syntax, and I have not used it a lot. I know, like if I had used, like if I'm using TypeScript for 2 years, I'll probably start being fine with it. I did an okay amount of JavaScript at different moments, but like not good at all.
Yeah, no, it's mostly the fact that there is type that is what is important to me more than the language,
Yeah.
because I'm always working on projects with many other people, and
Oh yeah.
type is what keeps the sanity and helps refactor at scale. And even before in the Valley, I worked on large like ad serving engines and stuff. A
Hmm.
lot of it in like C++ and Java, all typed systems, mostly to
And that's interesting. I'm probably affected by it. Like you say, I've never worked with other people in code bases pretty much. So yeah, type
That's
is
always a thing, right? Because like in JavaScript or something, you could easily type in nam instead of name, and then you'll only find out at runtime that you
yeah.
mistook. And there's like, and that's crazy amount of complexity I don't want to deal with. I mean, there's no
Yeah.
way.
No, that's true.
So
That's true.
I actually need to step off, I think,
Yeah.
unfortunately.
No worries. Have a good evening, and it was super good
Yeah,
talking with you.
it was great talking to you. We
We'll
should do this
see you on
again.
X. Yeah.
Yes.
Yeah. Bye.
Tarun, is Tarun still listening to us?
I don't know if we can be loud.
Okay, well,
Charoon.
I'll,
I don't know if it works.
oh, he's busy.
No.
All right,
Yeah.
chat later. Bye.
Yeah. Bye. Hmm? Merci. Hey, how are you? I'm good, and you? It was awesome. Yeah. So I think I'm gonna go. People didn't come around. That's perfect. That's good. Like, um, yeah. Oh, yes, exactly. It was fun. Thanks for inviting us. Thank you. Bye. Bye.
Yeah, we're probably gonna. Do we have any demos? Yeah, there was one. One demo. All right. I think I'm just gonna stop this.